Welcome to lesson number 2. We're looking at angles associated with parallel lines. So if you remember looking at parallel lines in other years or even other examples so far, you'll notice that parallel lines are always marked by an arrow. Sometimes they're marked with 2 arrows, and if there's more than 1 arrow, generally speaking, it just shows which lines are parallel to which ones. And so because there's only 2 parallel lines here, we use a single arrow. And a line that crosses a parallel line, so I have the line coming down through here, this line is called the transversal. So here's my transversal, and then my parallel lines are right here. I'm just going to call them P lines, and right there. Okay, so the first thing we're going to look at are some relationships that work out when parallel lines are formed. So the first thing we're going to look at are corresponding angles. Now, this first example is just going to go through an example of if you have a straight edge, so a ruler, and if you also have a triangle that you'll find in your, it's called the set square. So this triangle that you'll find in your geometry set is called the set square. If you use your set square and your ruler and you move it up and make several lines along your set square and your ruler, you're going to find something having to do with the angles. And the question you'll have to answer is, are they all equal? So if you want to pause the video, and try that now, you can go right ahead. So I'll give you a few minutes to do that. And so I'm going to continue now, but what you'll find is any pair of parallel lines make an F shape with a transversal that crosses them. And so if I have a parallel line and if I draw a transversal through it, it's going to make this the shape of an F, of the letter F. The angles marked A degrees are, so A degrees here and A degrees here. These are known as corresponding angles. The corresponding angles are equal. And so if I were to take my protractor and measure this and measure both of these angles, I'm going to get the same value for both of them. And so I get an angle of 70 degrees and I have another angle of 70 degrees. So on the diagrams below, we want to mark 3 other pairs of F-shaped corresponding angles, and we want to label them B degrees, C degrees, and D degrees. And so note that the F shape can be backwards, or it can also be upside down. And so I have one, and we want to do ones other than this one here. So let's try this first one. How we just make it opposite and upside down. And my opposite and upside down would be two corresponding angles right here. I could also do it upside down, go in the opposite direction as the one I just drew. And so this one here my corresponding angles would be found right here. And then on this last one, if I just do a mirror image of this up here, my angles are going like this. And this would be my last one. So those are our F-shaped corresponding angles. And remember that corresponding angles all equal each other. If I were to take the protractor of these, just like this previous angle, angles A, they're gonna equal one another. All right, now let's look at some example number 1. We want to use corresponding angles and straight angles to calculate the angles marked by the letters. So I want to determine what A degrees and B degrees are going to be. And so I'm just going to do this first example, and I'll let you guys do this one. But if I'm trying to determine what A degrees is, here's my corresponding angle. If I draw my corresponding angle here, or draw my letter F right there, and so my corresponding angles are found here, which means that A corresponds to 120 degrees equals 120 degrees. And if I use the rule we looked at yesterday, then supplementary angles are equal, which means that B is equal to 180 degrees subtract 120 degrees, or sorry, supplementary angles equal 180 degrees. And so 180 minus 120 degrees, we're going to end up with 60 degrees. And here, I'm just going to kind of walk you through where you have corresponding angles, but if you draw your letter F like that, you have your angle C here that corresponds to 124 degrees, and you can do the same thing over here, where your angle E corresponds to 132 degrees, and then you have supplementary angles that are also going to be equal to 180 degrees. Now, we're going to look at part B here, alternate interior angles, or Z angles. So in this diagram on the edge of the paper, we have two parallel lines, and then we have a transversal going through that make a Z. So if we extend two of the lines, then we make an X. So we extend this line down here and this line down here, and we have two equal angles that are opposite of this vertex. So this angle would equal this angle. Now, if we look at this, we have an F shape as well, so the top angle 80 degrees must be 50 degrees. Right, so I have an F shape like this and like that. So it's like a backwards F. So both of the angles of Z are equal as well. So what we want to do in this exercise is measure the angles in each of the following, and we want to determine if they are equal. So this one here I measure and I get 60 degrees. And I'll measure it here as well, and I get another 60 degrees. And we could say both equal 60. Here, if I'm looking at angle O here, and sometimes you're going to find that your book is hard to use your protractor with. You gotta get a flat surface. I get 40 degrees, and I got 40 degrees. So I could say that 40 degrees equals 40 degrees. And then lastly, I get about 105 degrees and 105 degrees by 105 degrees. And so yes, they are all equal. So that rule that we're going to be looking at is any pair of parallel lines that make a Z shape with a transversal that crosses them. So here is my transversal, here are my parallel lines, transversal. Any pair of parallel lines that make a Z shape with a transversal that crosses them have equal alternate interior angles, and sometimes we just call them alternate angles. And the rule we look at there is alternate angles are equal. So on the diagram above here, what we want to do is mark another pair of Z-shaped alternate angles and label them B degrees. Well, I have these angles that would be equal, so angle A and an angle A. But if you think about that, if supplementary angles are equal to 180 degrees, and if I were to call this angle here B degrees, then this angle would alternate with this angle here. And these two angles, B degrees and B degrees, would also be equal. We're going to look at class example 2 now. Use alternate angles and straight angles to calculate the angles marked by letters. Okay, so let's see if we have any alternate angles. And remember, with alternate angles, what we're looking for is that Z-shaped pattern. And so I actually have two Zs that I'm looking at. So the first one I'm looking at is right here, and that's with angle B. And so I'm just going to kind of outline it so it's a little darker. This is where the first Z I'm looking at is. And so angle B degrees is equal to 69 degrees, and because that's an alternate angle, right? So alternate angles are equal. And I have a second alternate angle right here, and that is angle A degrees, and that is equal to 47 degrees. And lastly, what we want to determine is what is angle C, and we're using straight lines here. But remember, angle C degrees, if supplementary angles equal 180 degrees, if this is my straight line, and these three angles are along that straight line, then angle A plus B plus C equals 180 degrees. So angle C is equal to 180 subtract 69 subtract 47, and that is equal to 64 degrees. All right, so with this next example, we will approach it the same way, and using straight lines as well as alternate angles. And so just to kind of get you started with your alternate angles, you have one here. So if you want to make a Z like this, you have a Z there, and angle D would alternate with 42 degrees. And you also have a corresponding angle because you have your F shape right here, like that. And another thing we have is we have an isosceles triangle, which means that this is also E degrees, right? Because isosceles triangles have two equal sides plus two equal angles. And if this is 42 degrees and this is E degrees, then this one over here must also be E degrees. So I'll let you figure out this one. But this is a really good example. Good question. Last, we're going to look at when a pair of non-parallel lines is intersect by a transversal, the corresponding angles and alternate angles are not equal. So if you don't have the line, like the arrow showing that it's parallel, then you can't use these rules. The corresponding angles aren't going to be equal, and neither will the alternate angles. And so if you don't have the parallel symbol with the arrows, then make sure you're using your protractor. But if we do have two parallel lines and a transversal, we're going to look at another set of angles that we have called co-interior angles, or C angles. And so these C angles, the reason they're called C angles is because they look like the letter C, right? So this looks like a C, this is kind of like a weird looking C, and then this is a backwards weird looking C. The angles marked O and X are my co-interior angles. And what we want to do in this investigation is just measure them. And we want to determine, are they equal? Well, you can basically just look at them and tell that they're not equal. One is greater than 90 degrees, the other is less than 90 degrees. And so, no, they're not equal. And you can just look at them and determine that. No, they are not equal. But if we measure these angles, can I discover a relationship between the values of O and the values of X? Well, let's see. This one's just a little bit hard to measure on my book, but X, this is 105 degrees. O, this measured to be 75 degrees. 75 plus 105 degrees is 180 degrees. Ooh. And let's look at this one here. Angle X is 120 degrees. And angle O is 60 degrees. 120 plus 60 again gives me 180 degrees. So we can make a conjecture that co-interior angles are supplementary. So example, they add up to 180 degrees. And we're going to be looking at that in lesson 3. This last example, though, we want to calculate the measures of the 3 remaining angles. So this angle, and this angle in this parallelogram. So there's several ways we can do that, but one way we could start is we know that if I have 48 degrees here, and if I look at this as just a letter C, I know that these are equal to this angle plus this angle are going to add up to be 180 degrees. And so 180 degrees minus 48 degrees, oh, sorry, I'm not even on the paper. So 180 degrees minus 48 degrees, if I look at this as my letter C, my co-interior angles, so I'm just going to look at this section here. And if I look at this angle plus this angle need to add up to give me 180 degrees. So if I subtract 48 from 180, I'm going to end up with 132 degrees right here. And since there are 4 sets of co-interior angles, and all of them would add up to give me 360 degrees, that means that my acute angle is also 48 degrees, and my obtuse angle here is 132 degrees. So in summary, what we learned today was when parallel lines are intersected by a transversal, they can form corresponding angles which are equal. We can have alternate angles which are also equal, and we can have co-interior angles which are supplementary. And if two transversals intersect two lines that corresponding angles are equal, alternate angles are equal, and co-interior angles are supplementary, then the two lines can be said to be parallel.